Welcome everybody to our webinar. We are pleased to host PMRs in airports and public spaces, improving accessibility, helping clean, and addressing labor shortages. And we're so thankful to our sponsor, the Center for Integrated Transportation and Mobility, or CITM, for their generous contributions to our events and our activities this year. We're here to talk about the opportunity of deploying public area mobile robots at airports and other large public facilities like shopping malls, hospitals, and entertainment parks. We're excited to bring together this group of speakers to share some results from their successful pilot projects. While most people in our audience may be familiar with robots being used for fast food deliveries or for floor cleaning, this pilot project involves 3 different use cases of robots, including an innovative wheelchair robot to support people with mobility challenges. On behalf of the Urban Robotics Foundation, I am delighted to introduce you now to our speakers. Richard Dunda, who is going to be our host today. He's the director of the Center for Integrated Transportation and Mobility, and CITM is a supporting member of URF. Matt Benson is a partner at Seamless Ventures and the program manager for FLITE, which you'll hear more about, at the Gerald R. Ford International Airport Authority in Michigan. It provides grants and pilot testing opportunities to companies focused on bringing emerging air travel technology solutions to the market. Vivek Burhanpurkar is the CEO of Cyberworks Robotics. Cyberworks is a CITM client and innovator of robotic platforms and mobile robots that include personal mobility vehicles, also known as wheelchair robots, autonomous tugs that move goods, and autonomous floor cleaners. Bernd Grush is the executive director of the Urban Robotics Foundation and the global lead for drafting the new international deployment standard for PMRs, public area mobile robots, and that's ISO 4448. I will hand it over to Bernd to please clarify the agenda and the learning objectives for today's webinar.
Thank you, Lee. Thank you for the introduction. Thank you, everyone, for attending. Thank you to our hosts, CITM, and to our panelists, Matt and Vivek. Thank all of you. So I am going to, in the next slides, speak about the learning objectives, and I'm going to take a moment to provide a definition. And part of that, I want to discuss the importance, I think, for autonomous wheelchairs. I've added a slide about that in a few moments. Then I will introduce CITM, which will then follow on to introductions to both Matt and Vivek at FLITE and Cyberworks. And therefore, following that, our discussions and Q&A. Lee will be back with us at the end. Thank you. So as Lee mentioned, there's really 3 key use cases that are all appropriate to airports. I think there's more than that, but right now there's 3 that we're going to be looking at through the pilot that we're going to be looking at today. Autonomous wheelchairs, floor scrubbers, and delivery cargo movement and delivery robots in that airport environment. We will look at some of the sort of the lessons associated from that project as well. There is a 3rd objective at the end to have you consider the potential of joining URF as a member and or CITM as a client, as we both work to support the growth of this industry. So the important thing is to notice a difference, or to be aware of a difference between a definition of an autonomous mobile robot or an industrial mobile robot, which we're all probably pretty commonly familiar with, but a public area mobile robot is specifically designed to travel in public shared pedestrian pathways. So there is not a visible human assistant. You'll see a short video of one of those such robots in a few moments. And you will see that there's no human assistant nearby or visible. Whatever degree of oversight is there, but there's not a human assistant nearby for that. They are, again, operating in public spaces. That's, where in general, pedestrians and other active transport use, such as cyclists and so forth, usually have the right of way. There's exceptions, but right now we're looking at the sort of the typical case, and they are operating amongst bystanders. And what's important about bystanders, the humans that are nearby, they are not involved with the robot's task. They're untrained to work with robots. They're unprotected, and they're inattentive. So that's an important element of this work that we do at URF to make sure that people are safe. So to make sure we understand where the entire element of these public area mobile robots sits within the entire realm of robotics. A subset of that is mobile robots. A subset of that we're talking about today is public area mobile robots. And a subset of that, which many of us are familiar with, these personal delivery robots or sidewalk delivery robots. And that is a subset of what we're talking about today. And that's only one of the kinds of robots. We're going to talk about a cleaning robot, which you'll see over on the right, in summer maintenance or facility maintenance. And at the bottom, you'll see mentioned wheelchairs. That's again an important focus of today's talk. So what I want to underscore before I turn this over to Richard is that autonomous wheelchairs are unique for a number of reasons. First of all, they very specifically and knowingly address labor shortages, which are the case for people working in airports, moving an increasing number of people that need assistance. There's an increasing growth in passengers and an increasing proportion of those that need assistance to get, from a ticket gate to a flight gate, and so on. It also addresses uncomfortable and anxious service delays. So someone who's waiting to be transported sometimes can wait quite a period of time, and there's some anxiety and discomfort for that. I think you can appreciate, especially if you've ever needed such a service, and that brings rise to special issues of social equity and accessibility to travel, for example. There are enhanced safety requirements because we're transporting a human. There's always safety issues with a mobile robot, but when you're also transporting a human, that compounds that issue, which means that those safety requirements will be enhanced in these cases. It's also important that ride smoothness be especially the case because of the potential of becoming getting motion sickness if you are a human traveling on these. That's not important for cargo, but it is important for human. And what's valuable is that smoothness, that what we learn in this world translates into ride value for all PMRs, which has an enhanced value for all the PMRs in the industry. This also contributes to an improved public perception in that not everybody loves delivery robots. There is a mixed feeling about them. There's a majority like them, but not 100%. But it's hard to bring the same arguments against a robot that is transporting a human that requires that transportation. So that would really be an important element of this as well. There's also a very high level of human to robot interactions that are necessary because we're in a crowded, complex space. It's actually more complex than a simple sidewalk because there's people milling around in a wider space. They can be milling around in clusters. You'll see that in the video today. So that's a complex interaction between robots and humans. And so basically the summary is that this device, the autonomous wheelchair, is unique for the intersection of healthcare, because what I didn't mention earlier, should have mentioned, is that this is also, what you'll see today is also applicable in hospitals. So that's where this intersection of robotics and health care and public service come together. So with that, I want to express our delight in having the Center for Integrated Transportation and Mobility. They are a member of the Urban Robotics Foundation. They are a sponsor of today's webinar. So I'm introducing Richard Dunda. Please introduce us, Richard, to OVIN, your work, CITM, and then kick off the discussion with our panel with Matt and Vivek. Thank you.
Great. Thanks very much, Vern. As Vern said, CITM is part of a larger network of technology accelerators that work with transportation-focused clients, funded by the province of Ontario, called the Ontario Vehicle Innovation Network. That's the province's premier program to work with innovators across a spectrum of technologies, right? And as an accelerator, our mission is to find smart, sustainable transportation solutions that are driven by small, innovative companies. And we do that by providing a comprehensive range of programs, services, and resources to those companies so that they can help grow and accelerate their technology. right? I don't have slides for this in the presentation. You will in the follow-up deck, but we do that by also partnering with an extensive network or ecosystem of partners, right? That includes companies like Magna, Parsons Transportation Engineering, McMaster University, Mohawk, quite a large list of partners in our ecosystem. And the number one thing that we try to do, or that we often get asked to do, is by a technology innovator, is have access, right, to a partner, right? Because that technology needs to be tested in a real world environment. That's part of what the services we've delivered for Vivek and Cyberworks Robotics. I want to make a plug for our own conference, which is on November the 7th this year. You can register online. It's free. Half-day conference going basically from 9 till 12:30ish. We have a great array of speakers for that, including a keynote by Dr. Ali Ahmadi, who runs the center, the McMaster Automotive Research Center, is the National Research Chair for Electrified and Autonomous Transportation. The closing keynote by Flavio Volpe, the CEO of the Automotive Parts Manufacturers Association. Panel members that include Magna, Linamar, Geotab, Vivek, right, is on our innovators panel. So I welcome you to apply or register at ftms.citm.ca. And now I'll introduce our panel. Matt Benson is partner at Seamless Ventures, right, and the program manager for FLITE at the Gerald R. Ford International Airport Authority in Michigan, where the pilot was done with the automated wheelchairs that Vivek's companies makes. FLITE provides grants and pilot testing opportunities for companies focused on bringing emerging technology, air travel technology solutions to market. He collaborated with Vivek, CEO of Cyberworks Robotics. Vivek is a CITM client, an OVIN program participant, and an innovator on robotic platforms and mobile robots that include personal mobility vehicles, wheelchair robots, amongst others, autonomous tugs that move goods, and autonomous floor cleaners. It makes a pretty sophisticated software stack that turns a regular standard device or machine into an autonomous transport machine. All right, and with that, I will hand it over to our panelists, right? We'll let them take the floor and we'll go from there.
Great, thanks, Richard. So if you go to the next slide, Lee, I think just a little background on FLITE and kind of setting a little context for the project. And I think really what FLITE is set up to do is get tech into the real world. So a lot of what Richard was just talking about, it's a similar goal of ours. And in particular, we're looking at getting innovators access to the airport environment. And I'm sure everybody can imagine that that's not the easiest thing to do. If you're an innovator knocking on the door of a large airport and saying, hey, I have this new thing that hasn't been done before, we'd love to try it out at your space. FLITE is there to make that conversation a little better and a little easier. We're looking at things across a lot of different areas. Essentially, the entire airport campus is our lab. And we're looking at things from, impacting the guest experience, looking at the future of aviation, looking at solutions that can assist with safety and security, electrification, and automation. And Cyberworks kind of hits a couple of those areas pretty strongly, obviously automation as well as guest experience. If you go to the next slide, I'll just give you a little bit of a sense of who is involved. We have the airport itself. So the Gerald R. Ford International Airport, second largest airport here in Michigan behind Detroit. A lot of, airlines, a lot of passengers, but still, not the biggest airport. So we are able to kind of have a little more manageable, flow, and we can connect to the leaders, and it's, really has been a great partner. The state of Michigan is a funder and a supporter, and really trying to help drive the mobility sector here in the state. And then the other partners are, we have an airline partner, Southwest. FLITE is a organization that provides a lot of services to both the airlines as well as to private aircraft. WMAA is the West Michigan Aviation Academy, is a charter high school that is here on campus, and we leverage a lot of the students to engage in the projects and provide them opportunities to learn from the innovators. And then Seamless is my organization that is kind of the manager of the program. And then finally, just in terms of like, what are we trying to do? If you go to the next slide, this, relatively common looking Venn diagram kind of highlights how we're thinking about the projects and questions we're trying to answer with projects. And roughly speaking, it boils down to understanding if people really want this thing. Is it desirable? Is it useful? Is it helping solve a problem? And is it something that people would either pay for or do the work to integrate? Does it work? And that has a lot of different angles to it. And then does it make business sense, essentially? And I'll let Vivek talk more about the specifics of the project, and I can kind of add some color commentary to that. But within the projects, and actually we've had both the autonomous wheelchair here, but also the floor cleaner as well. We certainly were interested in understanding, does it work? I mean, that's absolutely a big part of it. We spent a lot of time working with Vivek around how it could fit and integrate into the business model, which in a complex system like an airport, was really important. And then got a lot of perspective around the desirability side as well. So I think the workability or feasibility, does it work, was probably the major element of the work. But if you look across the work we're doing here, we've had a lot of other projects on automation, robots, both on the more industrial side, so things that are out on the airfield, but certainly inside the terminal and dealing with passengers. We actually have a charging robot that's about to be tested here in this current round as well. So we're looking at robotics, automation, and often it's a blend of these different topics that we're interested in. So with that, I think I'll let Vivek kind of color in details around both the project, how he connected with FLITE, as well as really what they're trying to do.
Yeah, thanks so much, Matt. Can we go to next slide, please? Yeah. So as Matt and Richard mentioned, in a nutshell, Cyberworks builds self-driving technology that adds autonomous functionality to third-party industrial products, ranging from everything from forklifts to floor scrubbers to wheelchairs. Next slide. Our roots as a company date back to the earliest days of the self-driving industry. Back in 1987, we were the first company in the world to manufacture an industrial autonomous mobile robot, and that basically kicked off the autonomous mobile robotic revolution. Since then, we've developed a myriad of AMRs in partnership with the world's largest brands that can operate in the most complex environments, including airports, without any operator interventions. In fact, through the FLITE program, in partnership with Matt's team, we operated our technology, both our autonomous wheelchair and floor scrubbers, for over 100 hours without a single intervention in the FLITE airport facility. Again, without a single intervention or failure of any kind. Much of that testing, as I said, was supervised by Matt and his team in FLITE. Next slide. Our business model is basically to license our software navigation stack to manufacturers of AMRs and industrial equipment like wheelchairs and floor scrubbers and so forth, thereby accelerating their product development cycles and getting these products into the marketplace faster than typically would be possible by a startup organization. Next slide. A prime example of our work with Bosch is on the Sunrise Medical autonomous wheelchair that you see in this picture here, and Matt is our model for the for the wheelchair. And that wheelchair, as I mentioned earlier, is able to navigate through complex crowds and operate in extremely large facilities, not just the GRR airport, but we've trialed the technology in much larger international airports without the use of any type of visual tags or beacons having to be placed in the building, which is pretty common to most other types of AMR technologies in the market today. Other unique features of our technology include the ability to switch on the fly between full self-driving mode and what we call a smart manual mode of operation, which allows the passenger to have the autonomy to move around the airport wherever they want to go, whether it's to a kiosk or a restaurant or a restroom. They can also receive Google Map-like visual directions via our graphical display, which makes it really easy and fun to navigate around. Next slide, please. As well, our navigation software stack has a long list of unique advanced features not found in AMRs currently available. I won't go through the entire list, but it's very, very feature-packed, feature-rich technology that's a lot of fun to use and very easy to use. Earlier, I think Bern touched upon the issue of motion sickness. One of our unique features is a very, very elegant motion planning capability that basically eliminates the tendency towards motion sickness with other types of wheelchairs in the market. And in the next slide, you're going to see a short video, a 30-second video of it operating in the airport under the FLITE program.
Thank you so much, Vivek. Now we'll move on to Richard, if you want to begin the panel discussion. Thank you.
Great, very much. Thanks, Lee. I'll start with maybe Vivek and Matt, and you could talk to your aspects of this question. So what were the goals at the airport, right? So Vivek, this is directed to you, but they're aligned. Matt, you can speak to your goals. What were the goals of the project at the airport? Did you achieve those goals from your perspective, Vivek? And Matt, did they map to the goals that you were trying to get out of this pilot project?
Maybe I can go first. Our goal was to really figure out what we don't know. Until you get into an actual live airport environment, you don't know what you don't know. What kind of situations can arise? What kinds of requirements had we perhaps not been aware of previously when we were just testing in other types of environments? So I think that was probably the biggest goal. Is are there things that we don't know, things we don't realize that are going to be important in a live airport environment? In our case, we were happy that the experience in the airport confirmed that we had addressed everything possible. We didn't get any surprises, but that was really the main intention, is to understand, did we discover anything really surprising that we hadn't thought of before?
Yeah, and I would just kind of add to that. I mean, as I said, one of our biggest goals was really trying to understand, does the technology work? And largely what we meant by that, I mean, there's a lot of different aspects. I mean, we had a spreadsheet with about 50 line items on it that we wanted to investigate and see during the testing, but a lot of it was really what you just saw in that video is, can it navigate through a crowd, and how does it impact those other people? So it's not just the passenger in the wheelchair, but the other travelers. How are they interacting? And just as a small example, one of the things we wanted to understand is like how fast the wheelchair could go, because we had a certain mathematical equation in mind for how many passengers could be handled by a wheelchair. But what we found pretty clearly, and I think Vivek already knew this going in, is that what the technical capabilities of the chair were for how fast it could go isn't how fast you want the wheelchair to go, both for that motion sickness topic, but also for the other travelers who might be walking through. And there's a lot of challenging spots in airports. I mean, people who are hopping off a plane and running for a restroom and might step out into the flow of traffic. And if you're two humans walking, that kind of interaction might result in just a bump. But we wanted to make sure that when we we did some unfair things in a way, like we gave Vivek a list of here are all the things we want to see, and then our team kind of interjected surprises. Essentially, we moved things into the path, because that happens in airports. We had people behaving in ways that weren't necessarily completely expected, and we tried to understand how does the chair react in those situations. And as Vivek said, across the 100 hours, we didn't see any issues. And I guess the other key goal, which was really important to our team, was understanding the setup process. When a company comes on site and says, "Hey, we're going to set this up," this is really still early days. I think there's not a lot of these devices in airports and even in any locations yet. We wanted to understand, what would be involved in mapping, testing, training the devices, et cetera. And that was really quick. Essentially, we scheduled a whole week for that activity. And I think, Vivek was basically done in a day with that process. And I think we wanted, it was surprising, but we also wanted to give him a chance to be successful. So we wanted to kind of see how it would go. So our goal was really trying to understand all those aspects. Does it work? How does it fit in, and how do people interact? And then I guess finally, just I'll put a shout out. The company that currently provides the service for wheelchair support, wheelchair pushing at the airport, is a company called Prospect Airport Services. And we were really interested in having them engage with the technology, because I think in a real world scenario, it's going to be really a partnership between the the human folks that are doing that service, as well as these automated devices, because not every passenger will be met by the needs, or their needs won't be met by an autonomous device. You may still need some humans in the loop. And likewise, with an individual trip, there might be portions of that trip that you'd want to have involvement from humans. So we were really interested in seeing how these devices will interact with the systems that are already in place and with those people that are working in these roles.
After setup, what kind of human intervention and monitoring is required?
So the amount of intervention that's required is really a key topic in terms of almost all autonomous mobile robot technology. The number one goal commercially, the reason why you deploy autonomous mobile robots is to reduce operating costs. There are lots of other good reasons, but that tends to be the bottom line. If you're not reducing operating costs, then the project's a no-go. You don't sell anything. And a key aspect of that is minimizing human intervention. So that's been a core focus of our technology development program over the last 10 years as a company. Not just having robust technology, but ensuring that you don't need intervention. So after the installation process, our goal was always zero intervention, zero requirement for human input, and I think that's what we saw in the FLITE program when we were operating in the airport. I think we took about 6 hours to install the machine so that it could go everywhere in the airport, like map the entire airport, pre-TSA and post-TSA. And after that, it basically did not require, to the best of my recollection, it didn't require any interventions, which was exactly the goal that we had in mind. There is optionally, we did provide a fleet management system, so somebody at a central control station or remote location can monitor all of the wheelchairs or all of the autonomous robots in the facility or multiple facilities, but there's no need per se to do so. The machines can operate on their own from the touch screen, which can be operated by the passenger. So.
Okay. You mentioned labor, and whether this is displacing labor or addressing a labor shortage. And Matt, maybe this is for you. How are your company and the companies or the clients that you work with, how are you thinking about technology like this?
Yeah, I mean, I think Vivek nailed it on the economic side, is obviously a big factor. I think also, there's just a reality that a lot of these jobs are hard to fill, both in terms of just, are there people available for those roles? So I think it varies a little bit, but I would say for the airport and for the, folks that are part of the FLITE, sponsor group, I think for the most part, we're thinking of, how do we augment the teams we have with these technologies to, provide, a even better service. So like at a wheelchair, it might be that there's, I mean, I don't want to be quoted on a number, but this is being recorded, but, maybe it's 50% of trips that people are taking from, security to gates, can be met with an autonomous ride, as an example. And some of the other ones need some assistance. I think in the case of cleaning, you still might have a cleaning crew doing work, but the scrubber is operating kind of independently, kind of nearby, and you're able to maybe get more done with slightly fewer people, or those people are able to do a more thorough job that you have. In the case of I guess just as another example here at the airport, one of the challenges we have on the air side of the operation, where FAA is involved, is today you basically still need a person there ready to kind of hit a kill switch if something goes wrong. So the economic model for automation in some of the other places are a little bit more difficult to make sense, just given regulation. But in the terminal, we see it as a way to kind of get a better level of service with the same workforce that's kind of possible to have, and potentially over time you can move those folks to other roles. But it's not so much about the problem. The big pain point right now is lack of staff, and we're trying to find a way to manage that.
Okay. I'll ask one more question, then I'll hand it back to Bern for him to ask. So you alluded at regulatory issues there, right? Are there regulatory conditions or barriers that need to be addressed? Right? Often regulations lag technology, so that's kind of to be expected, right? And if there are, how do you see them? What makes sense to modify them in the future to?
So on the air side of the operation, I kind of alluded to, like, there are some FAA conversations that need to happen and kind of review, and that's a little separate from the conversation. I think inside the terminal, I'd say more than regulation, it's really like liability conversations that are driving the bigger driver. It's like, whose insurance? How do you show how do you build confidence? I think part of our project is really building confidence for the decision makers and teams, and then deciding kind of how to constrain things in a way that put the right scope on whatever is happening, so that you can kind of progressively move that. I think everyone is very concerned. I mean, this population we're talking about, relatively frail, in some cases very frail. You want to treat them very carefully, and I think we're going to be very methodical in kind of how that rolls out. Just for that reason, I think regulation, there's some things around security, getting through TSA, that are considerations, but they're somewhat trivial, I think, relatively, compared to really the just focus on the people who we're serving. And then there are probably some cybersecurity things as well, which come into play at airports that need to be thought about, and that that's kind of downstream stuff in a way. But within the project, our biggest concern was the people, and just making sure it was safe.
Yeah. Richard, thanks. I think you want me to inject a question or two.
To you, Bern.
Thank you. So I'd like to ask Matt, and I think all of us, or most of us on this call, certainly Matt and Vivek, know that there's multiple categories of people who require assistance, mobility assistance in an airport, and many of those more complex circumstances. And these are people that, for example, are unable to climb stairs, or unable to navigate their own way into their seat and so forth. And these people cannot be helped by the kinds of robotic technology that we have so far. And these people need human assistance. Still a wheelchair involved, they still need human assistance. And the numbers that I have, and from an expert I believe in in Italy. His name is Roberto Castiglione, and he pointed out in an interview that I had with him a while ago that something on the order of 1.2% of trips, these are European numbers, I think, that's my recollection, but in any case, they would be similar here in North America. About 1.2% of travelers require assistance of the kind that is possible robotically. And there's a smaller percentage that absolutely need human assistance, and then the rest would be able to travel on their own. Is that your experience, Matt? Is that, like, in other words, that number of 1.2%, does that sound about right for the U.S. experience? Or your experience
it sounds plausible. I don't think I have a number, so I wouldn't want to completely endorse it, but it sounds plausible. It might be even a little higher. And I think what we see is certain flights, certain routes tend to have higher incidence, which frankly is one of the other reasons, right? So in addition to like staff, there are these high points that you just need a lot of service at all the same time, and trying to hire for those peaks can be really difficult. So, even I think use cases where you say, hey, here's a device that can be, kind of used under supervision or some level of, coordination with a human. I think that's a scenario as well. But I think, certain times of year, I think, you've all experienced, this is like a time of year where you can have a lot of families traveling, or this is a business travel day. Like these are the other situations. It's not just the overall percentage. It's, a percentage at this moment.
Yeah, managing peak is going to be a very important issue. I also understand that these numbers are growing. I don't know how fast they're growing. I've heard different reports from different companies. And some of those reports might be exaggerated, but the number of 1.2% seem to be quite a conservative number. You can understand that they would be growing in some populations because populations are aging. So one of the problems with labor is when you have an aging population such that the older people in that population need this assistance, and then there's fewer younger people in that same aging population to provide that assistance. Robotics such as autonomous wheelchairs I believe they will become indispensable if we want to continue to provide the kinds of services they're going to provide. That's not a question; it's just an observation. And if there's a question buried in there, it's whether you agree with that or not, I guess, Matt or Vivek. But I don't think we can escape the labor question. And that's important because not everyone's happy with the view of replacing labor.
I just want to add in, there's a question in our chat from Mark Turpak from Virginia Tech, and it's, I don't know, maybe Vivek, because I know you deal with clients all over the world. He says, do the trends mentioned apply mainly to US and Canadian airports, or are they similar elsewhere? For example, labor shortages and increasing demands for wheelchair assistance. He says, anecdotally, I'm not noticing anywhere near the volume of wheelchair assistance in European airports that I note in the US. It might be shaped by various factors, including differences in regional travel choices and options, example, train versus flight.
That's
yeah.
Go ahead, Vivek.
Yeah, I think the trends vary country to country. Specifically Europe, we are talking to airports in Europe, and they're telling me the same things and giving me roughly the same numbers that I'm hearing in the United States. So I don't have any official numbers, but again, anecdotally, I think we're seeing the same thing in Europe as we are here in North America.
Yeah, and I think there are differences also in terms of how it is provided. So in the U.S., basically, if you ask for assistance, you're going to get it. And I know anecdotally there are countries, Middle Eastern countries in particular, I've heard a lot of very high interest in this kind of tech. To the extent is it a what kind of what's driving it? I guess that's a open question, but this is something that I'll say when we talk to other airports, it's a very interesting topic for them. It's kind of what we've learned and what we've seen. So that's not limited to North American airports. I think we're hearing it from others as well.
I want to throw in another question, and probably this is going to be to Vivek. I know, Vivek, you said in your introduction that you build autonomous stacks or mobility stacks for multiple kinds of robots, and I know you specifically talked about floor scrubbing and cargo moving. First, two questions here. What is this sort of technical overlap that you can extract by working at a platform level instead of at a specific application level? And the second aspect of that is, as we have more and more kinds of robots, will we deal with an orchestration problem? So you can just imagine an airport that has, let's say, 5 or 6 different types of robots for 5 or 6 different types of activities. Even Matt mentioned one for a robot for charging, for example. That's a 4th kind of robot already. So if there's 4 or 5 different kinds, and each kind has multiple instances of, in other words, the total fleet could be several hundred at some point. How do we orchestrate? Have you thought about that orchestration problem? I guess that's to Vivek, or to either Matt or Vivek.
Yeah. So I see that as that question had 2 parts to it.
Yes.
So in terms of our navigation stack itself, we've worked very hard for the last 10 years in R&D mode, or stealth R&D mode, to ensure that instead of having different software stacks for different use cases, we have one unified stack that applies to all autonomous mobile robots. So we install the same stack in everything, whether it's a forklift or a wheelchair. And there are on the application layer level, we allow the ability to kind of customize the application layer. Obviously there need to be differences in the way you operate an autonomous forklift as compared to a wheelchair. So it's one stack, but it's customizable on the application layer very easily. That allows us to keep our development process very tight and very focused. And one innovation that we develop, maybe as we develop an autonomous forklift, can also then be applied very quickly and easily to everything else, whether it's a wheelchair or a scrubber. So multiple applications actually benefit each other, or innovations that we make in one test environment will benefit another. So that's sort of a little bit about the architecture of our stack. It's not a bunch of different stacks. It's a single unified system that we use across the board for all vehicle types and all use cases. So it's entirely vehicle agnostic. And,
Yeah, I guess.
yeah.
Oh, I was going to just add, like, I think, as a flight program, like, we're not really trying to answer, is autonomy in these situations like something that happens anymore. Like, I think we've seen enough examples that, organizations like Cyberworks are able to do it. I think the question becomes, for that application, how are people benefiting? How are you kind of tweaking and maybe changing things like the speed and the turn radius to deal with human behavior and kind of motion sickness and things like this. So my gut feel is like the tech stack is basically all the same on the autonomy side, with pulling different levers in settings for different applications. That a floor scrubber, when it's going to go get to the place where it's going to do its job, can move in a straight line. It's probably at night, you're not going to have a lot of people around, you're still watching for things, but you don't need to have all the same settings you might have in a crowded terminal, but it's the same basic concept.
Yeah, I want to throw out another question, and this one's straight to you, Matt. And this is a selfish question. I am the drafter of an ISO standard for the behavior of these devices, and you mentioned a very enticing list. You said you had a list of about 50 things that you wanted to look for. And so, but I'm not asking about how that list worked out in this particular case, but the actual contents of that list would be a checklist for our standard. It could be a checklist for our standard as well. I don't know if you would see that checklist as useful for that, in that regard. But if you do, I would very much like to collaborate with you on that level of, because you have a view, you have the facility management view that overlaps with the roboticist view, but the standards view is about deployment, is about facilities management. So your view, your questions are very, very close to what we at the ISO need to deal with. So,
yeah, I mean, I'd be happy to talk further on that. I mean, it was everything from like, the size of the seat to the way, passengers are walking through the terminal received a warning to, what happens when you have a individual walking out in front. There's all these different, scenarios we were concerned with. We also were interested in the, how does someone tell it where you want to go? And then there's regulation about a wheelchair trip needs to offer, a stop at a restroom, needs to offer a stop at a restaurant or food option. So how does that all occur?
Yeah.
And the user interface side, that wasn't our main focus, but we certainly were interested in trying to understand how that would play out.
So there's one of the key things that you just mentioned has to do with warning, and that is part of the standard. And some of the other things are not, because they're very specific to airports and so on. But we'll come back to that later. I think, Lee, you have other questions?
Yeah, there's a question in the chat from Brandon. Says he's currently on the IEEE humanoid study group, and one of the things we're looking at is how self-balancing robots might work in public spaces. Can you comment on how robots on legs or Segway style balancing on wheels might be received in an airport space?
I mean, Vivek, you might have thoughts on this too. I mean, for me, it'd be really interesting to understand that. I mean, there's like, in some ways, like FLITE would love to try that out and see. It does feel like, in comparison, there is some anxiousness, I think, that people first see especially when you see a chair without a person in it. It's more interest generally. It's more excitement, more like, well, what's going on? But people still, kind of take a step to the side. And I imagine a more humanoid shaped robot might, have more of that. I think people have seen the videos and obviously like sci-fi things, and probably they'd be a lot of different ideas be going through their head. But that's why putting it into real world is interesting. I think it'd be fun to try to understand that.
Yeah, from our perspective also, I think there are some practical advantages to legged robot or even more so a Segway style robot in terms of maneuverability in a crowded environment like an airport, as well as the footprint, saving a lot of storage space. That's one of the big issues with these wheelchairs, is that where do you store them, where space is at a premium in an airport or a hospital. So we've actually been thinking about it. We'd be very interested in partnering with you folks on something like that, because the navigation component is the same. We would use the same navigation stack because you still need to be able to figure out how to get from A to B and how to avoid obstacles in your path, unexpected obstacles when you're going from A to B. So the navigation aspect, you know, we would almost our entire stack would still apply to that kind of use case.
Wonderful. Thank you so much. I'm now just going to wrap up with a quick couple of slides to say thank you, everybody, for participating. If you haven't already downloaded the Executive Guide to Public Area Mobile Robots, it's available free on our website. And also for any members, it's actually not just a member discount, but you also would get a free discovery guide if you wanted to join in the next month or so. And I want to do a special shout out and thank you again to CITM and also all of our sponsors and partners and members for your support. Richard or Bern, I don't know if you had any other closing comments, but I just wanted to say thank you, everybody, for attending. We will be publishing the video on our YouTube channel shortly, and we'll also announce it in a blog post and email to everybody. Thank you again.
My final comments, thanks to everyone. That's the only comment I have. Thank you all.
Yeah, just a thank you to Vivek and Matt, and a comment that, you know, it takes companies like Matt's that are willing to trial technology in the real world in order to help innovators like Vivek move that technology forward. You can only do so much in a lab or a simulator, right? So kudos to you, Matt, and thank you again. And Vivek, thank you I know you've been at this for a long time. Thank you for continuing to pursue the innovation dream.
Thanks, everybody.
Yeah, thank you.
Thank you all.
Needed to have the conversation.
Thanks, everyone.